They were just solving a system of equations by another method. So once again, mathematicians just really took a deep dive into solving systems of equations with 3 variables and 2 variables too. And they found all these different ways. Like, their brains think on a different level than mine, that's for sure. But they were sitting there and they could see things that we can't just see, and they were able to figure out, oh, this is another way to solve. So today we're going to first learn how to find the inverse of a matrix, and it's only doable if it's a square matrix. And they're only going to ask you to do it to a square matrix, and we're going to find the inverse, and then we're going to use the inverse in the future to solve. So we find out in the future, we can take this certain matrix, find the inverse of it, and then what you do to get solutions is you take that inverse new matrix that's now an inverse and times it to the equal stuff. In a minute it will make sense, but right now we're just finding how do you find an inverse, because you got to be able to find the inverse first. So everybody, we've got to memorize this. If it's a 2x2 matrix, there's a formula that you can do it with, and you'll want the formula. It's way easier than doing it the long way, and we are going to have to do it the long way for 3x3. So this right here tells you how to find the inverse of a matrix if it's a 2x2 matrix, which would be square. So if this is a matrix and it's sitting in these positions, A, B, C, D, what you're going to do is you're going to do 1 divided by the diagonal multiplied, subtract the diagonal multiplied. This is just how I memorize it. So you're going to do A times D. Everyone, do you guys see what I mean by the diagonal being multiplied together? Yes? This is just me memorizing it with you again right now. Then you're going to subtract B times C. See, multiplication of the diagonal. See, that's what happened right there. A times D was subtracted to B times C. So that's just how I memorize it. I say, so I'm doing 1 over the multiplication of the diagonals with a subtraction sign. Now you have to keep things straight. Haven't we taken a matrix and multiplied stuff together and in between it was an addition sign? Yes. That was last time, right? That was when multiplying matrices. So you can't get all this stuff backwards. I think that's the hardest part of the unit, is keeping everything straight and not messing up on negatives or like forgetting what goes where. Now that's not it. So that's just going to be a number. Think about it. If you times a number and then subtract another number, won't you just get like 1/5, 1/20th? Do you guys see what I'm saying? It'll just be a number. And then that number will be multiplied in last, but then we've got to also switch up the matrix. So let me tell you what you do. So what you're going to do is take the first diagonal and you're just going to switch them positions. So that means then D will go here and A will go here. And then what you do is with the second diagonal, you keep them in the same position, but you put negative signs on them. Now we're not getting into, so why does this create the inverse? Remember, we're not getting a degree in math right now. You don't need to understand the deep of, let's go into what, that would take a whole lesson in and of itself. So if you decide to get a degree in mathematics, you'll learn these kind of things like, well, why do these work? Okay, so here we go. We're gonna find the inverse, here we go, of this matrix. In the future, we'll use it. Right now, we're just learning how. We're not seeing how to use this. So what you're gonna do is memorize. You're gonna do 1 over the multiplication of this first diagonal. So it'd be 1 times 4. Then it's a minus sign in between. Then you're multiplying this diagonal. This is memorization. Then you're going to times that number into, look at the pink diagonal. We have to memorize it. Didn't I say to switch those? So you leave the signs alone. You're just switching them. So this will be a 4 and this will be a 1 now. Then the blue diagonal, you keep them as is, but you change the signs to opposite of what they currently are. So this will be -2, -3. I guess I should check to see if I have that memorized correctly. I do. Okay.
Wait, what's the point of the formula?
What?
What do you do with the formula?
Now we're not done. So now we gotta finish. I was just looking back to make sure, because I have it memorized just because I've done it for so many years. You know what I mean? I was looking back like, oh, do I still have that memorized correctly? Okay. So now let's do it. So that would be 1 over 4 minus 6, which is actually 1 over -2. Now we've got to go times that into 4, -2, -3, 1. So our final answer will be, we know we're allowed to do this. This is why we took last time's lesson and learned you can multiply numbers into a matrix. So isn't that 4 divided by -2 is -2? Same thing as timesing by -1/2, right? -2 divided by -2 is 1. -3 divided by -2 is 3/2. And 1 divided by negative 2 is negative 1/2. So this would be our inverse. Right now we're just finding an inverse. We're not using it, but in the future we're going to use it. Questions? If you got them, please ask, because remember, you guys are the first time I'm teaching it, so I learn a lot from you guys, and then I can always teach it better in my next period, because you guys bring up stuff. Okay, so if two matrices are really inverses of each other, which we just found this, didn't we? Did I mess it up? I thought I had found the inverse. Did I do that correctly? Did I mess something up? Oh, it's different. It's not even the same original start. Okay, good. All right, so here's the thing. I've already went through and said, okay, here's my original matrix, and I found the inverse. What happens is if you were to multiply something by its inverse, all of the operations kind of like cancel out in a way, and it gives you the identity matrix. So if they ever say to you, prove that these two are inverses of each other, you'll have to do multiplication, which remember is when you do multiplication, it's the long process. Remember from last time, you would say, okay, so I'm going to start with this, and then I do this times this plus this times this. Do you remember that, everyone? And then we would go, okay, and then we do this times this, or sorry, 3 times negative 2 plus 4 times 3/2, and then it gives you the answer. Anyways, so it would give you the identity matrix. So cool. I'm not going to prove it to you. We don't have time. Think about this. When could a matrix inverse not exist? Like, what if we were going to calculate a square matrix inverse and something came up that was a problem? If you look at this formula, can anyone possibly, without me telling you, if not, that's okay, but I just thought I'd give you the opportunity to think, is there a potential with this that could be an issue? If I'm like, go calculate the inverse, and you're going to calculate, and then you're like, oh, can't do that. Yes?
When AD minus BC equals 0?
Yes, when AD minus BC is 0. If that just happens to be 0, wouldn't you agree that's not possible? So it's not that you messed up, it's just you can't find its inverse. Like you would say it doesn't have an inverse. Its inverse doesn't exist. Okay, very good. So just be aware of that. If you're doing 1 divided by 0, you'd say can't find the inverse. All right, now listen to how we do an inverse of a 3 by 3. This is quite the process. There is no magic formula, sadly. We wish there was, like a 2 by 2, but there really isn't, or they just give it to us. So here's what we do. To find the inverse, we're going to go like this. We're going to put the matrix in a big augmented matrix with an identity matrix of the same size. So obviously this is a 3 by 3. We're going to do an identity matrix of a 3 by 3, which remember is 1's along the diagonal, 0's above and below. So we literally insert this in, and now we have to go through the very long process of get a 1 here, 0 below, 1 here, 0 below, 1 here. Then we'll get a 0 above, and then what happens is they switch. Now this side will be the 1, 0, 0, 1, 1, 1, 0, 0's above and below, and over here will now be numbers. Do you guys see what I'm saying? If we're doing all that, won't that switch everything along? You know what I mean? So now the 1's will be over here. I just said that's what we're doing is 1, 0, 0, 0, 1, 0, 0, 0, 1. Isn't that what I just said we were doing over here? Yeah? There'll now be new numbers over here. And then you'll say, oh, that's my inverse. Let's do it. So we got to be, this is very, 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 you got to be so careful. We saw this 2 lessons ago where like you can't make any errors. And now there's 3 additional placeholders that we've got to be careful on. So it says find the inverse. So let's all lock in, do not zone out or you're going to get lost. Because remember, it's just a lot. So it says find the inverse. You'd say the only option is to insert the identity matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1. All right, our goal is to now switch these to be over here, the 1's and 0's below on this side. So we have to get a 1 in this position. So let's write our formula. How do we get 1's? We times by a constant. So what are we going to do? Row 1 times 1/2. Which equals new row 1, yeah? Times by a half, 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 times by a half. Okay, so let's write down our new matrix, if you don't mind. So row 1 now just became a 1 and a 3/2 and a 1/2. and a 1/2, and a 0 and a 0. 2 didn't change, so write 3, 3, 1, 0, 1, 0, 2, 4, 1, 0, 0, 1. Now I was tempted, just so you know, just because I got to bring this up, I was tempted to take this row and switch it with this row, which is doable. Remember, that's allowed, right, everyone? But here's what people mess up on. They only switch this, and they leave these alone. No, like, you got to switch the whole thing. Do you guys see what I'm saying? So just make sure you take all the 0s and 1s if you decide to switch a row. But we didn't do that, so that's fine. Let's just keep going. We now know that we use this 1 to get a 0 right here and right here. Let's just focus on writing a formula for getting a 0 for the 3. So we obviously need to use the 1 from the diagonal because that's what we learned last time, or 2 times ago. So what are we going to do with row 1? Times it by what? -3. We're going to add it to row 2, and that'll equal our new row 2. Let's write our other formula if you don't mind as well. Let's now focus on 2. We use 1 from the diagonal, so obviously we're starting with row 1 to write our formula. So row 1 will be times by? Everyone? Anyone? -2 added to row 3 equaling new row 3. Does everyone see why? They're trying to make that position added to be 0. Yes? The position we just said, 2, needs to be 0. So if we're using 1, of course we're timesing by -2. Okay, let's just now focus. These are separate problems. Let's just focus on doing, I'm going to put a box to keep my brain looking at these. I'm timesing those by -3. So what's 1 times -3? -3. I'm timesing that by -3. Timesing that by -3. Isn't that -9/2? Times that by -3. Yikes. Times that by -3. -3/2. Times that by -3, times that by -3. We're then adding it to row 2, which is 3. There's going to be lots of adding fractions, it looks like. So I should have left room to add the fractions. I have some over here on the side. Okay, let's add straight down now. So we're getting 0. I'm going to go off to the side. I don't want to mess up at this point. At this stage would really suck. I'm like not even close to being done. 9/2 plus, or -9/2 plus 3 over 1. I'm timesing by 2 to the bottom and to the top. -9/2 plus 6/2 is -3/2. Did I do that right? Now I'm adding straight down -3/2 plus 1 over 1. So I'm timesing by 2 to the bottom and to the top. -3/2 plus 2/2 is -1/2. Luckily, -3/2 plus 0 is an easy one. 1 plus 0 is 1. 0 plus 0 is 0. And that's my new row 2. Okay. Let's now focus on pink box. And we're timesing these numbers by -2. So if we times that by -2, we're putting -2. If we times that by -2, we get -3. If we times that by -2, -1, -1 again, 0, 0. Since 0 times anything is still 0. Current row 3 is 2, 4, 1, 0, 0, 1. Current row 3. So now I'm going to add straight down. You guys see I just put in current row 3 so I can make sure I don't make errors. Lined it up. Yes. Add straight down, we get 0. Add straight down, we get 1. Add straight down, we get 0. Add straight down, we get -1. Add straight down, we get 0. Add straight down, we get 1. And that's my new row 3. All right, we need to rewrite our whole problem now. So look back at this matrix. We didn't change row 1. So write 1, 3/2, 1/2, 1/2, 0, 0. Row 2 just became 0, -3/2, -1/2, -3/2, 1, 0. And then 0, 1, 0, row 3, 0, 1, 0, -1, 0, 1. So I got a 1 here, and then I got the zeros below. I'm now at the point where I need to get a 1 right here. We're going to get 1 by timesing by a number. If this needs to be 1, what are we going to times by?
Nothing. Can't we just add it?
We don't get 1s by adding, because that would be out of the suggestions, which can cause issues other places. Negative 2/3, you guys. You just, like, think about it. You gotta flip the fraction, right? Because that would be then 1, because then there's a 2 on top and a 3 on bottom on both. And then they're both negative so that it's positive 1. So now go like this. That's going to be 0, 1. Looks like that's going to be, let's look really carefully. I don't want to mess up now. I like to see them right next to each other. That's why my brain's not seeing it. 1/3. I'm going to write it right next to it. It's just not worth making an error on. Isn't that a positive 1? Or am I crazy? Negative 2/3 and 0. There's too much going on in there. I'm personally rewriting it. Like I said, trauma from the past, messing up at some point when it was just, it's just not worth messing up on. To me, it just doesn't bother me that much to rewrite it. And if it will save me from having to redo the problem later on. Negative 2/3, is that what that was there? 0? 0, 1, 0, negative 1, 0, 1. Okay, we're doing good. Just take a deep breath. It's all going to be okay. I know it's a lot. 1, 0 is below. We got a 1 here. We now know that the goal is to get a 0 right here. And you always use this 1 to do it. So we know we're going to start our formula with row 2 since we need to use the 1 from the diagonal. So we're going to say row 2 times negative 1 added to row 3 will equal our new row 3. It's just now there'll be a 0 where we want it, right? So I'm going to put my box around row 2 and say, okay, I'm focusing on timesing these by negative 1 and writing the result. 0 times negative 1 is 0. 1 times negative 1 is negative 1. 1/3 times negative, 1/3 times negative 1 is negative 1/3. 1 times negative 1 is negative 1. Negative 2/3 times negative 1 is 2/3. And 0 times negative 1 is 0. Current, I'm writing down now current row 3. 0, 1, 0, negative 1, 0, 1. I'm going to add straight down very carefully. 0 plus 0 is 0. Negative 1 plus 1 is 0. Negative 1/3 plus 0 is negative 1/3. Negative 1 plus negative 1 is negative 2. 2/3 plus 0 is 2/3. 0 plus 1 is 1, and that's my new row 3. So I'm looking right here at this matrix and saying I only changed row 3. So I write 1, 3 halves, 1 half, 1 half, 0, 0. Row 2 is still 0, 1, 1/3, 1, negative 2/3, 0. But now row 3 is 0, 0, negative 1/3, negative 2, 2/3, and 1. Okay, so now I'm trying to zoom in at least. So I say, okay, I need to get a 1 here, 0 is below, 1 here, 0 below. I'm now at the point where I make this right here a 1. We're only going to do it by timesing by a number. So what are we timesing by? That needs to be 1. Yeah, negative 3. So we're timesing it to that, which will be 0, 0, 1, 6, negative 2, and negative 3. I'm just personally rewriting it. 1, 3 halves, 1 half, 1 half, 0, 0, 0, 1, 1/3, 1, negative 2/3, 0, 0, 0, 1, 6, negative 2, negative 3. We really are actually pretty close to being done with finding the inverse. So we get a 1 here, 0 below, 1 here, 0 below, 1 here. Yeah? Now just focus on getting a 0 right here and right here. So we make sure that we use this 1 to get 0. So we know we're gonna write our formula with row 3, since that's the one from the diagonal, and that's what I recommended. So row 3 needs to be times by, let's focus on a third. We're trying to make that 0. So what does row 3 need to be times by? Negative 1/3, then added to row 2, equaling new row 2. I'm gonna give myself plenty and plenty of room, so I'm gonna go down a little further. Now let's write a formula for the 1/2. We're using the red 1. So we know we're starting with row 3. We're writing our formula with row 3. We use the 1 from the diagonal always. So wouldn't we be timesing by negative 1/2? Because we know we're adding them, right? And they need to be opposites, everyone. So I'm just writing both formulas down. Then we're gonna add it to row 1 and it will equal our new row 1. It's just now row 1 will have a 0 where we want it. Then I go put a box around, okay, this is where I'm focusing on timesing by, and now the problems are totally separate now. So do row 3 times negative 1/3. So won't that be 0, 0, negative 1/3. 6 times negative 1/3 is negative 2, I believe. That is going to be negative 2 times negative 1/3 is positive 2/3. You can see, like, what if I wrote down negative 2/3 right now? That would suck because the whole rest of the problem would be wrong. I'm not done. 0. Oh, no, whoa, my brain. That's why I have that box there. See, my brain went up on accident. That times negative 1/3, isn't it 1? Write down current row 2, which will be 0, 1, 1/3, 1, negative 2/3, 0. We then add straight down 0, 1, 0, negative 1, 0, 1. And that's my new row 2. So that one ended up being nice. Like I didn't have to end up adding fractions on that one, at least. Now we're going back to the pink box and we're focusing on timesing those numbers by negative 1/2. 0 times negative 1/2 is 0. 0 times negative 1/2 is 0. 1 times negative 1/2 is negative 1/2. 6 times negative 1/2 is negative 3. Negative 2 times negative 1/2 is positive 1, I believe. Negative 3 times negative 1/2 is 3/2. We then write down current row 1. Remember, current row 1 is right up here. So I'm writing down 1, 3/2, 1/2, 1/2, 0, 0. I just wrote down current row 1 so that they're stacked on top of each other, so when I add straight down, I'm not messing up. 0 plus 1 is 1. 0 plus 3/2 is 3/2. Negative 1/2 plus 1/2 is 1/2. Okay, now I'm going to have to go off to the side and add this one because I want to make sure I get it right. That's negative.
You just said that negative 1/2 plus 1/2 is half.
Oh, yeah, that would have been so bad. So it's a good thing we're working together. So I add straight down, we get 0. I'm not going to lie, I know exactly what was happening. My brain was thinking also about other things. I got to stop doing that. Okay, so we're adding straight down. Negative 3 plus, I can't read it. Is it 1/2?
Yeah.
So now we're getting a common denominator times the bottom and the top by 2. Negative 6/2 plus 1/2. Negative 5/2. Add straight down, I get 1. Add straight down, I get 3/2. And that's our new row 1. And we need to rewrite the whole thing. I'm out of room. Hopefully you guys have more room. So this was the matrix. We just fixed row 1 to be 1, 3/2, 0, negative 5/2, 1, 3/2. We are really close to being done, guys. So we're just like, take a deep breath. Row 2 is 0, 1, 0, negative 1, 0, 1. And row 3 didn't change. 0, 0, 1, 6, negative 2, negative 3. I got to write with better handwriting so I don't get confused later. Okay, once again, you go 1, 0 below, 1, 0 below, 1, 0 above. We only need a 0 right here, and you're only going to do that by using this 1. So we know we're going to write our formula with row 2. Since we need to use 1 from the diagonal, that's positive 3/2, so we need to times by negative 3/2. So when we add them together, it'll be 0 right there. So then we're going to say row 2 times negative 3 halves plus row 1 equals our new row 1. I'm going to put a box on this and say, okay, I'm focusing here on timesing those numbers by negative 3 halves and writing the result. 0 times negative 3 halves is 0. 1 times negative 3 halves is negative 3 halves. 0 times negative 3 halves is 0. Negative 1 times negative 3 halves is positive 3 halves. 0 times negative 3 halves is 0. 1 times negative 3 halves is negative 3 halves. I'm then writing current row 1, which is 1, 3 halves, 0, negative 5 halves, 1, and 3 halves. I just wrote down the current row 1 as it currently is so that they're stacked on top of each other. Then I'm adding straight down. 0 plus 1 is 1. Negative 3 halves plus 3 halves is 0. 0 plus 0 is 0. 3 halves minus 5 halves, luckily, already has a common denominator. 3 halves, you guys right, minus 5 halves. Isn't that negative 2 halves? Which is negative 1. 0 plus 1 is 1. Negative 3 halves plus 3 halves is 0. And that's my new row 1. So, my new row 1 is 1, 0, 0, negative 1, 1. 0? Feels so long. And then I need to write down row 2 and 3 as is. 0, 1, 0, negative 1, 0, 1, 0, 0, 1, 6, negative 2, negative 3. And guess what? We're done because, look, now do you guys see what I was saying about the 1s and 0s switching to this side? So that's your inverse. You write that in its own matrix. Negative 1, 1, 0, negative 1, 0, 1, 6, negative 2, negative 3.
I thought you said we would have to solve for that same thing.
No, we're not. This isn't, we don't have context right now of like, why do we need an inverse? That's what I was just kind of giving us a preface of like, in the future, we then now have to take an inverse and actually times it to something, which we haven't even got. Because this right now just is like, find the inverse. There's no context of why. Crazy. Wow, look at that. That should make you feel good. That you got it right. Nothing feels better than when it's a problem like that and you're like, oh my gosh. And then you go check your answer and it's freaking right. Like, it gives you a high. And it's not even drugs. Okay. All right, everyone. Can we agree that do we get the process? Do we really need to see another one from start to end? You can just see that you've got to be careful. Okay, now I'm just reminding you, okay, if they say find the inverse on the test and it's a 3 by 3, once again, we insert it with 1, 0, 0, 0, 1, 0, 0, 0, 1. Yes? Yep. Okay, if we see a 2 by 2, we can do that, but no thanks. Like, we could insert it with 1, 0, 0, 1 and go through, but no. Instead, let's use the formula, which we know is 1 over, I'm not going to do it, but I'm writing it down. Isn't it 1 over 12 times 3, this diagonal? Minus sign. We have to memorize it. In this one, it's a minus sign. Negative 7 times negative 5. Tons of negatives going on. You can't make errors. Then you're memorizing it with me. The first diagonal just gets switched. So 3 goes up here, 12 goes down here. The second diagonal stays, but the signs change. So positive 7, positive 5. We would then go calculate this number down here. It's 36 minus, and then this is 35, because a negative times a negative is positive. So that's 1 divided by 1, which is 1. When we times 1 to that stuff, we just get that stuff. So I said we weren't doing it, but we ended up doing it anyway. Woo, there's our inverse. So yeah. Okay, let's see how we use this, okay? So here we go. I'm going to be honest with you. I think it actually will make more sense if I show a problem and then come back and say like, well, why does this work? If I say why it works right now, people are like, oh, they overcomplicate it in their brains and they think like, oh no, this is hard. And I'm like, no, you need to memorize that this is what you do. So what I'm going to do is show you this is what you do. And then you'll be like, oh, cool. And then I'll go say, but here's why we did that. And you'll go, oh, okay. So let's just go to a problem, everyone. Okay. So you can solve a system of equations by using an inverse. And here's how you do it. So you've got to keep this straight in your head. There are different methods, and you will get confused if you don't nail this down in your head. If they say solve by row echelon form, you need to put this in one big matrix all together. I'm not doing this way, but I'm reminding you. Yes, everyone. It's one big matrix. We would then get a 1 here, 0 below, 1 here, 0 above, and then wouldn't our solutions be listed? Okay, that's just row echelon form. What's different about this form is you actually don't put this into one big matrix. You kind of split this up. So what you do is you put this in its own matrix without the variables. So we're using the coefficient 3, 8, 4, 11. So this is the coefficients of your variable matrix, the coefficient variable matrix. And then we put this in its own matrix. So go like this, 5, 7. We put the equal stuff in its own matrix. Then what we do is we actually find the inverse of this, which will be doable, isn't it square? We find the inverse of that. Let's do that. So let's go off to the side and say, okay, I'll come back to you later, 5, 7. Okay, let's find the inverse. So we know it's 1 over 3 times 11, minus sign, you're okay, 8 times 4, yeah? And then we're putting our matrix in. We're just focusing on doing the inverse right now. We take the first diagonal and we switch positions. So this will be 11, this will be 3. We take the second diagonal, we leave them in place, we change the signs. We now need to calculate this number. Isn't it 33 minus 32? Well, we're looking out. That's 1 divided by 1, which is 1. We would now take 1 and multiply it to that stuff. So what we do is we go like this. 11, negative 8, negative 4, 3. And now, this is what these mathematicians discovered. Okay, you can take the inverse, and then you can multiply it to the matrix of the equal stuff. And this is important. This has to be listed second, I think. Yep. Why do I know that? Because, well, let's see. Isn't it true that when timesing a matrix, it's not always doable? Let's write down the size. Isn't this a 2 by 2? We do rows by columns. We know that. So isn't this a 2 by 1? Row by column. So we know if you're able to multiply a matrix, then the number inside has to be the same, which it is. And then the outside numbers are the size of our new matrix. So we have a 2 by 1 matrix, which I recommend drawing in a visual aid over it. So 2 rows, 1 column, like that. And then remember, this is row 1, column 1. So we go like this. We're going to box row 1 and go down column 1. And now we're doing the multiplication of things sitting in the same position. 11 times 5. What's the sign in between? Plus, right? You can see how there's just so much to remember. And then there is things sitting in the same position of negative 8 times 7. So that's 55 plus negative 56, which is negative 1. Guess what? You just solved for x. X is negative 1. This is row 1, column 2. So, wait, is that right? That's wrong. I wrote that down. I knew it was weird because I looked back at my matrix. I'm like, wait, that's not right. Isn't this row 2, column 1? So I should be boxing row 2 now and boxing column 1. We then multiply things sitting in the same position. So negative 4 times 5 added to 3 times 7. So isn't that negative 20 plus 21, which is 1? And you just solved for y. So you just found your solutions, negative 1, 1. We just solved by matrix inverses. So you kind of have to memorize that that's what you do, you know, like find the inverse and then times the equal stuff. I feel like I can teach that better than most teachers. Here's why. They try to go into, and now I'm going to explain, like, okay, so why is that, like, how do they even figure out to do that? I actually can explain that pretty quickly. But most teachers start with that, and then kids are like way confused. In fact, when I first started teaching, I feel like I didn't teach that as well. Okay, so let me explain something, okay? So I just told you that we can take a system of equations. Here's my system, right? Okay, so watch. I'm going to show you like why this even works. It's actually pretty straightforward. But I'm not going to show this ever again, so just listen. You might not even need to write it down because really you just need to memorize that that's what you do. But I wanted to show you real quickly. So these mathematicians are like, let's write this stuff in the variables in their own matrix. So I'm going to quickly do that. 2, 3, 1. Just watch 3, 3, 1. You really don't need to write this down because you don't ever have to do this. I'm showing it because it is actually kind of interesting. And then they said, okay, but we can't just ignore x, y, z. So they times by x, y, z like this equals, and then they wrote the equal stuff in its own matrix, 4, 2, 5. Now it makes sense of why this is equivalent to this. This is called a matrix equation, not an augmented matrix, a matrix equation. Think about why this makes sense. With multiplication, don't you go over, down? Yes? Over, down? Right, everyone? So look, that makes sense. Look, if I say go back that way, you would say, so it's 2x, 3y, 1z. And you would say, and it's 3x, 3y, 1z. And then it would be 2x, 4y, 1z. Because you multiply things sitting in the same position. So they're equal. Okay, now look, if I said to you, just use basic algebra here to get these by themselves, if those are by themselves, won't it be x equals y equals z equals? Basic algebra? Well, undoes multiplication. So I'm going to divide by this matrix, 2, 3, 1. 3, 3, 1, 2, 4, 1 to both sides.
Oh, but instead of dividing, we just multiply by its inverse.
Exactly. And dividing matrices is not doable. So now look, isn't XYZ by itself? But dividing matrices is not doable. So they're like, well, how can we make this a multiplication problem? Well, this is technically an exponent of 1. So they're like, let's just flip this back over the fraction. 4, 2, 5, and then write this as a matrix like this, 2, 3, 1, 3, 3, 1, 2, 4, 1, and call it a -1 exponent. And now it's a times problem, right? That's how negative exponents work. You can flip it down, you can flip it back up. And then by definition, that means calculate the inverse and then times it to the equal stuff. But the equal stuff can't be in front because the order then doesn't work. We know, like, okay, so then let's instead put it on this side, 4, 2, 5. Do you guys see what I'm saying? And then we can multiply it, and boom, that will be your x, y, z. You know what I mean? It makes sense. It's just basic algebra, actually, but it's kind of crazy that they thought of that. All right, so let's just do one from start to end again. We already done one. Let's do a 3 by 3. Bless our souls. Okay, whew. All right, I got to do some meditation before I get this going here. Okay, we really should only probably need one example, so that's the good news. So you do have to memorize. If they say solve by matrix inverses, you have to memorize how to set that up. It's different than row echelon form. Row echelon form is put it in one big matrix. This is different. So you're going to put this stuff, the variable stuff, in its own matrix. 2, 3, 1, 3, 3, 1. 2, 4, 1. And don't we need to find the inverse of that, everyone? So we need to then insert 1, 0, 0, 0, 1, 0, 0, 0, 1. Before it was a 2 by 2, so we didn't have to do all this BS. We just said, okay, let's find the inverse using the formula real quick. So we're like, okay, and then we'll write this stuff in its own matrix, but we won't use that clear till the end. So we're like, we'll come back to you way later. And then, we already just do this one? Is this the one we just did? These numbers feel too familiar. Okay, so we would pretend for a minute. We'd get a 1 here, 0 below, 1 here, 0 below, 1 here, 0 above, 0 above, yeah? And we would then have the inverse, and we just found it 2 examples ago. So what was the answer after all that? Remember, this was the big drama fest here. So this is what we would have done on the test at this point. And I need you guys, because I can't flip, wasn't this the inverse? So I need you to now tell me that so I can rewrite it down, and then I'll give you a second to write it down too. So what was it, if you don't mind?
-1, 1, 0.
Okay.
-1, 0, 1.
Okay.
6, -2,
-3. Okay, I'll give you a second to write that down. I'm going to just erase this, make it a little prettier. So you would memorize, okay, I'm going to go through and find the inverse, and then I'm going to write it in its own matrix. Then I'm going to insert the equal stuff on the right side, 4, 2, 5. And then I'm going to multiply This is a 3 by 3, and that's times to a 3 by 1. So we can multiply them. Our new matrix will be a 3 by 1. 3 rows, 1 column. And then this is row 1, column 1. So we're going to box row 1 and go down column 1, multiplying things sitting in the same position. So you would say -1 times 4 is -4, plus 1 times 2 is 2, plus 0 times 5 is 0. So aren't we getting -2? Then this is row 2, column 1. So now I'm done with that. I'm just moving on to this. So then I'm doing -1 times 4 is -4, plus 0 times 2 is 0, plus 1 times 5 is 5. So I'm getting a 1. Then I know this is row 3, column 1. So I'm scribbling that out. Now I'm focusing on this. I'm then doing 6 times 4 is 24, plus -2 times 2 is -4, plus -3 times 5 is -15. I think it's 5. 5. That's what I saw too when I looked at it originally. Okay, 5. So isn't this x, y, z, everyone? X, y, z. So there's your answer. X, Y, Z. So we just found 3 planes intersecting. We just found it using this new form. It's using matrix inverses. So, but keep in mind, right, like that would have been an entire problem. Like this would have been then, now take this, you know what I mean? And then continue that. So it's just a long problem. Now, here's what I know that they usually do on the test, and it makes sense of why they do it. Think about what they do. They're going to have a problem where they just have you find the inverse so that they can see you know how to do it. Like, you know? Then they're going to do this, and you know how many people get this wrong, and I'm crying for them? They then give a problem. They want you, of course, they're going to put a problem where they make you solve by matrix inverses. Why would we learn this if they're not going to even put one on there? So guess what they do, though? They will list out the inverse for you. They say, here is inverse of that, and they'll give it to you. Do you guys see what I'm saying? So then they say solve. Well, if they've given you the inverse, then what do you do with it? State it again, and then do what with it? Multiply it by the equal stuff. Do you guys see what I'm saying? So literally it's a multiplication problem. They're testing, but do you know what to do with the inverse? That's really what, you know what I mean? So if you miss that, you're like, what the heck? Every student that does test corrections goes back and goes, wait, all I had to do was take that and times it by that. Everyone's like, yeah, because that's how you solve by inverses. You take the inverse and times by the equal stuff. So you just have to know that that's what you do, and then it will be a multiplication problem for you. That one problem will be a multiplication problem. Okay. All right. So my question is, would you like to see one from start to end, like where we have to find the inverse, then take the inverse and times the equal stuff to it?
Same numbers,
It's the exact same numbers again?
but with different answers.
Oh, that's stupid. Okay. Well, I mean, I guess so it's stupid because then I can't give you any more examples. All right. So one more recap. We're not going to do it, but what you would do is you would put 2, 3, 1, 3, 3, 1, 2, 4, 1 with 1, 0, 0, 0, 1, 0, and then 0, 0, 1. Do you agree? We then go through, and it's going to take a whole page, and we're going to find the inverse. We're then going to write the inverse in its own thing. So you'll have a number, yes? And then you'd say, and now I need to times it to the equal stuff. 11, -2, 15, which will then give you your solutions, x, y, z, because you'll be going over and down. Then you'll go over and down. Then you'll go over and down, and that will be a number, a number, a number. Okay, cool. I think on the homework they do that too sometimes. They'll like give you the inverse. So, I don't know. I did the key a long time ago. So hopefully, it's not that it's like really hard. It's just long. Start practicing so I can help you if you're stuck.